These are video notes on calculating discounts and markups. To start, we're going to look at a couple quick definitions. A discount is when you get to pay less for an item. So if it is a 20% off discount or a $2 off discount, it means that you get to save money and pay less for what the original value was. Another example, if you have a 25% off discount, then that means that you would save $10 off of a $40 dinner. Typically, you're going to be using subtraction at some point to make your amount smaller. A markup is pretty much the opposite. Instead of looking for a smaller number, a markup is going to be a higher number. Usually a store will charge a markup on an item so that they can make money. That's how stores are going to stay in business. An example of that, if a store buys a pair of shoes for $50, they might have a 30% markup. That means that they're going to sell them for $65. So every pair of shoes, the store would make $15 in profit. All right, we're going to start with an example. If we have a shirt that is originally $35, but there's also a sale for 25% off, we want to know what our sale price would be. We're going to start by finding 25% of $35, and the way that we can calculate that out is multiplying our original cost by the 25%. And whenever we're using a percent in our computations, we're going to write it as a decimal. So we would just multiply $35 by 25 hundredths, and that would give us an amount of 8.75. In this case, that represents an $8.75 discount. So that's the amount that I don't have to pay. So I could then subtract it off of 35 to find the amount that I do have to pay. And that's going to give me an overall cost of $26.25 after I subtract. All right, next we're going to look at a skateboard on sale for 20% off. Same steps as before. We're going to start by finding 20% of $50. So we would multiply 50 by 2/10. When I do that, it's going to give me a $10 discount. And I could then subtract $10 from 50 to get a sale price of $40. Okay, next to same idea, except we're going to be doing a markup. So I will still start with finding 20% of $70. So multiply 2/10 or 20 hundredths by 70. That's going to give me a $14 markup. And then instead of subtracting my markup off, I would just add it. So $70 plus $14 gives me a selling price of $84. Okay, next one, a store pays $75 for an aquarium. Markup is 20%. What is the selling price? So we are going to find 20% of 75, which is exactly $15. That's my markup. And then when I add that onto the selling price, or the original price, I will get a selling price of $90. All right, for the final two, we're going to work backwards to find the original cost and the percent. So for this one, a store is charging $50 for a video game. That's after a 20% markup. So we want to find the original cost to the store. For this one, I'm going to set it up as a proportion. If they are selling it for $50 and that's after a 20% markup, then the $50 is going to represent 120% of the original cost. Okay, and just as a side note, that's my 100% plus my 20% markup. That's where the 120% is coming from. And in my proportion, I'm going to set that equal to what it would be at 100%, since 100% is going to represent the original price. And I'm looking for that value right there. I have a couple different options for solving my proportion. I'm going to go ahead and use cross products to set up a new equation. So I'm going to multiply x by 120%. So that's 120x. And then I will multiply 100% by $50, which is going to be 5,000. And then from here, I can divide by 120 on each side to get x by itself. And unfortunately, this one doesn't come out to a nice whole number. If you divide that out, it's going to come out to 41, and then it's going to be 0.666 repeating. Since we're talking about money, I want to round to the hundredths place. So I would say that x is equal to $41.67. Looking back at my original proportion, that would be reasonable. $50 was after the markup, so I'm looking for a number that's less than $50. And so if I do 20% off of 40, that would get added back on, and that would equal exactly 50, taking into account that I am rounding to the 67 cents. So my original price is $41.67. Okay, and finally, a store purchases an item for $20 and they want to earn a profit of $30. So what percent do they need to mark it up? I'm going to start off with finding the actual sale price. They bought it for 20, they marked it up 30, and so that's going to give me a sale price of $50. So now I just need to find what percent the markup is. 50 is after the markup, so I could write that $20 represents my 100%. So that's going to be my original price. And in my proportion, I want to figure out what the markup price is. So that's going to be my variable, and that's going to correspond to my sale price of $50. Now I just need to solve my proportion. This time it might make more sense to simplify the first fraction. If I divide by 10, or yeah, I could divide by 2 and get 10 over 50, and then multiply by 5 to get my x value. So 50 times 5 tells me that my markup total percentage is 250%. Now remember, 100% represents the original price, and I want to know just how much to mark that up. So basically what I'm going to do is subtract off my original price, and I'll be left with a 150% markup. And then again, just to show how that would work, I could plug it in to test it. So if I have a 150% markup, then I'm going to find 150% of $20. When I multiply those two together, that's the same as doing 1.5 times 20, and that's going to come out to $30. That matches what the markup amount was going to be. And 20 plus 30 is 50, and that represents the sale price that I knew I needed to sell this for. Okay, so if you are trying to work backwards, a proportion would be one good way to set this up. Again, discount means that you're taking money off. Markup means that you are increasing the price by a certain amount. So hopefully that helps with discounts and markups. Thank you for watching.